Hi guys, I hope you're having fun while I'm at the Mets game. Yay! Sorry, not Trebiton, but I'm happy I'm at the Mets game. I hope. I'm making this a week in advance. I hope it'll be nice weather. Anyhow, so here's 2016 number 5, which looks a lot more complicated than it actually is. So for A, you have to find the average value of the radius. So remember, average value is 1 over b minus a, the integral from a to b of f of x dx. Okay, so the average value is going to be, 1 over, it's from 0 to 10. So b minus a, 10 minus 0 is just 10. The integral from 0 to 10 of our function, this is the only function that we have, so 1 over 20, 3 plus h squared, and it's going to be dh instead of dx. Okay, and that's all we have to do is to solve that. So what I would recommend is to pull this 1/20th out to the front, and in doing so, I'm going to erase this over here. We will get 1 over 200, the integral from 0 to 10, of 3 plus h squared dh. This is a non-calculator question, so we're going to have to do some things by hand. So we're going to get 1 over 200, and now we're going to do the antiderivative. Okay, and now we're going to substitute those values in. So when I substitute 10 in there, I'm going to get 3 times 10, which is 30, plus 10 to the third power is 1,000 over 3. It's going to be that, minus what happens when we put in 0. When we put in 0, we just get all zeros. So I'm just putting that there so you can see it. You don't have to. Okay, let's simplify some more. So we'll find a common denominator. This is a non-calculator question. Again, I'm just mentioning that. We get 1,090 over 3. Multiply it out. So we can take away a set of zeros here. We get 109 over 60, and we're talking about inches. And that was the answer. And the point values are, I'll get a color for that. If you just set up this integral, that was worth 1 point. If you found the antiderivative, that was worth 1 point. And then the final answer was 1 point. So that was pretty generous points for not too difficult of a question. Okay, now we're on to part B. Part B is just asking for the volume of the funnel. So as soon as you see volume, we're looking at this formula over here, which is just pi r squared, and f of x, that's really just your r. Okay, so we're just going to plug into that. So we have the pi, our integral from a to b, so that's from 0 to 10 again. Right here, it's 0 to 10. And then r is this 1 over 20 times 3 plus h squared, and that's all squared, and then it's dh. Okay, and because it's no calculator, we're going to have to do some work by hand, but that's okay. So let's first simplify a little bit. So 1/20th to the second power is going to be 1 over 400. And then we have 3 plus h squared, all squared, dh. Okay. Now, what I'm going to do is I'm going to pull this 1 over 400 out to the front. So I'm going to get pi over 400. So the integral from 0 to 10. And I'm going to expand this. So this is 3 plus h squared times 3 plus h squared. Okay. And I'm just going to multiply this out. So when I do, I'm going to get 9 plus 6h squared plus h to the 4th dh. And now we're ready to find the antiderivative. So we have 9h plus 6h to the 3 over 3 plus h to the 5 over 5 as it goes from 0 to 10. So since we have to do this by hand, I'm going to simplify this piece right here to make the numbers a little bit easier. Okay, so that's what we're dealing with. Make some room up here. Now we're just going to do some algebra. Let's get rid of all this junk. Okay, so we have pi over 400. Alright, first we're going to put 10 in there. So 9 times 10 is going to give me 90. Plus, if I put 10 in here, 10 to the third power is going to give me 1,000, and 1,000 times 2 is going to give me 2,000. And then for this one over here, if I put 10 to the fifth, that's going to give me 100,000 over 5. And then we have to subtract what happens when we put 0 in there, but you can see when you put 0 into all of these, it just wipes the whole thing out, so we don't have to worry about that. Okay, now we're just going to add this all up. Okay, so we're going to get 2,090 plus 100,000 divided by 5 is 20,000. And simplify some more. This is going to give us 22,090. Okay, it's really like over 1, so I'm just going to multiply straight across. I don't know what's happened to my equal signs. Okay, so we get 22,090 pi over 400. And I'm back. I paused this while the stupid phone was ringing. Okay, so we're going to simplify these zeros. Whoops. It was like that. Sorry, it was 22,090 pi over 400. Okay, cancel these zeros, and we have 2209 over 40 with a pi on the top. And the volume will be in inches, and because it's volume, it's cubed. Okay, and that's our final answer, so let me tell you the point values. Okay, if you had the original integral, which I've erased, that was worth 1 point. The antiderivative, that was worth 1 point. And then this final answer over here, that was worth 1 point. Okay, now we're up to part C. And there's a bunch of information there. And let's see what they're telling us. So let's see, there's liquid coming out from the bottom. That's over here. We're interested in when the height is 3. So let's write that. H is 3. The radius is decreasing, so that's going to be dr over dt. I hope you're recognizing this as a related rates problem. It's decreasing, so it's going to be a negative at a rate of 1/5. So negative 1/5. What is the rate of change? So that's our find of the height. So find dh over dt. And how do I know I'm using dt? Because it says with respect to time. Okay, so the only formula that I have is this one, which is my r. Okay, so r equals 1 over 20, 3 plus h squared. So since I'm going to have to take the derivative of that, I'm going to expand this first, make my life a little bit easier. Okay, so all I do is distribute that. And now I'm going to take the derivative. So dr over dt is equal to 3 over 20, that just becomes 0. And now we can just use the power rule, so I bring the 2 down, so I get 2 over 20 h dh over dt. But obviously 2 over 20 is equal to 1 over 10, so I'm going to simplify that and substitute at the same time. Okay, so dr over dt is negative 1/5 equals 1/10, right? 2 over 20 is 1/10. H is 3. and dH over dt is what we're looking for. Okay, I'm just simplifying. And then I'm going to multiply both sides by 10 over 3. So on the right, this all cancels. And 5 goes into 10 2 times. We get negative 2/3. And let's see what we're talking about here, inches per second. So our final answer should be negative 2/3 inches per second. Okay, that's the final answer. Let me give you the point values. Okay, so if you found this, why is nothing happening? My pen stopped working. There we go. Okay, if you got this, that was worth 2 points, and then the final answer was worth 1 point, and that finishes that problem. Okay, now moving on to 2015 number 2, which is a calculator problem. Okay, this one is just complicated because they gave you crazy functions to use for the calculator. It's just really unnecessary, but okay, let's do one thing at a time. So for part A, we need to find the sum of the areas of regions R and S. So we're going to do the area of R, and then we're going to do the area of S, and then we're just going to add them together. Okay, so R and S are both labeled in here, but you have to figure out which function is which. So if you put either or both of these functions into your calculator, you will find that this one that's up here, that's your g of x, and the one that's over here, this one's your f of x. So actually I think what I'm going to do is I'm going to use 2 different colors. So I'll make like a little key for you. So g of x is the orange, and f of x will be the yellow. Alright, now let me get a regular color. Okay, so the area of R is going to be an integral from 0 to something, and that something is right here. We're going to figure that out in a second. Oh my goodness, what just happened to my picture? Hang on. Okay, I'm back. I lost the whole thing and I just put it on pause and redid the whole thing to get you back. Okay, so the area of R is going to be the top function minus the bottom function. Okay, so we have the integral of the top function, which is g of x, right, that's the orange, minus the yellow function, which is f of x dx. Now you could actually write out the entire functions if you want. It's just that's kind of annoying. Okay, the only thing is that you need your integral limits now. So we know it goes from 0 to something. That something will be the x value right here. So how are you going to find out what that x value is? Well, you're going to put these 2 functions over here into your calculator, into y1 and y2, and then you're going to see where they intersect. And you're going to find that they intersect at when x equals 1.03283. Okay, so we're going to do the integral from 0 to 1.03283. Now, if you don't want to have to keep writing that number over and over, you could just like write somewhere on the side. You could say like let b equals 1.03283, and then you could just write b instead of that number, as long as you just make a little key so they know what you're talking about. Okay, and when you put all that into your calculator, then you're going to be careful because these are like crazy functions. You're going to get 0.997427. Okay, that's the area of R. Now we have to do the area of S. So the area of S is going from that 1.03283, and it stops over here, which is 2. They gave you that. And this time it's the opposite. So the yellow is on top, so it's f of x minus g of x dx. Put that in your calculator and you get 1.03283 2.06919. So we're supposed to find the sum of the areas. So you're going to take those two areas and add them, and you're going to get 2.004. Okay, let me give you the point values. If you found where they intersect, that was worth 1 point. If you set up this integral was worth 1 point, and this integral was worth 1 point. So 2 points for the integrals, and then the final answer that was worth 1 point. So that was 4 points for that whole piece. Okay, now we're moving on to part B, which is just talking about region S. So we're just interested in this region over here, forget R. And I see the word cross-section. So as soon as I see the word cross-section, I'm stopping, I'm making an integral, I'm writing area of cross-section. And then I'm looking to see what it needs to be perpendicular to, and it says perpendicular to the x-axis. So I know I have a dx, and I'm looking for x and x. Okay, so I know my integral, just for s, is going from 1.03283 to x equals 2. Okay, now I just have to do my area of the cross-section. Okay, so what is my cross-section? It is a square. I'm just going to erase this maximum. Okay, so the area of a square is equal to the side squared. Okay, so what is a side? So a side would be the length from, like, let's say here to here. So that would be f of x minus g of x. That would be one side. So we have to square it. Okay, so now I'm just going to replace that for this, the area of the cross-section. So I have f of x minus g of x all squared dx. And for this, we actually did have to find the volume. So you're going to put this in your calculator carefully, and you're going to get 1.283. And let me give you the point values for this one. So if you set up the integral right, that was worth 2 points, and the answer was worth 1 point. Okay, and now we're up to part C. So they're saying h is the vertical distance between f and g in region S. So here's region S, and the distance is just going to be this line right here between f and g. So h is equal to that distance, which is the yellow one, f of x, minus the orange one, g of x. Okay, so that's our h. And we're being asked to find the rate at which h changes. So that's going to be h prime. Now, if you're thinking, is this related rates, dh over dt? No, because it's saying with respect to x. It's not saying with respect to time. Okay, so h prime is going to equal f prime of x minus g prime of x. And we're supposed to find h prime when x is 1.8. So h prime of 1.8 is going to equal f prime of 1.8. Wherever there's an x, I'm putting in the 1.8 minus g prime of 1.8. Okay, so how are we going to find f prime of 1.8? Well, you could find the derivative of this, and then you're going to substitute 1.8 in there because you have your calculator, or you could do the easier thing. You go into your calculator, and you're going to go into Math 8, and the calculator will do everything for you. So f prime of 1.8 is going to be 2.116283 minus, and then you're going to do the same thing, Math 8, for the g prime, and you're going to get 5.9280072. So you have to subtract those two things, and you're going to get negative 3.1172. And let me give you the point values for that. If you found h prime, and come on, that was pretty easy, that was worth 1 point, and then the final answer was worth 1 point. And that finishes that. And I would highly recommend that you practice doing this with the Math 8 on your calculator, so when you have to do it on the real test, you'll be able to do it very quickly. Okay, see you guys tomorrow.